Hello, everyone. I'm Gary Berman from DevOps.com and the host of the Cyber Hero Adventure Show. It's a pleasure to welcome you to another great DevOps.com webinar. Today, we're going to learn about integrating data security into the DevSecOps toolchain. But before we get to today's presentation, let's go over a few housekeeping items. As you see, we use the GoToWebinar system, so for many of you, you'll see the control panel. Please take a moment to click on the questions icon, the little downward arrow. We love questions. This webinar is designed to be highly interactive with our great speakers, and they have some super cool stuff. We welcome your questions, comments, and suggestions in real time, and we'll get to as many as possible. If for some reason we can't get to your question, we'll make sure to email the replies to you shortly. We'll also have several poll questions so we can hear from you, and keep in mind, there are no right or wrong answers, so whatever you think. You'll also see some incredible demonstrations, so make sure to send in your questions. This webinar is being recorded and the slides will be available to you on demand at DevOps.com in a couple of hours. Additionally, great news, we have a giveaway for $25 Amazon gift cards at the end of today's webinar, so stay tuned to see if you are one of today's random lucky winners. And now, a special thank you to our sponsors for today's webinar. Arvind Tripathi, Security Architect at Fortinet, and David Green, CRO at Fortinet, are going to share with you some super cool information about what's happening in DevOps. Welcome, everyone.
Great, Gary. Thank you very much. And thank you, everyone, for joining our session today. And Gary, I've never actually spoken to a live superhero before, so this makes it even more exciting event. So thank you for that.
Well, and I'm on your side, so that's good news.
even better, even better. Well, again, everyone, thank you for joining us. And Arvind and I are pleased to share with you some thoughts about how to integrate data security into DevSecOps. You know, as I was doing some preparation work for the session, I found on DevOps.com this cartoon from 2015, bridging the gap between DevOps and security. And I'm guessing that some of you are joining us today because you feel like the guy in blue there laying across between the two cliffs and getting walked on by the rest of the organization. Although it would not be a lot better to be the guy in green where you've got to rely on someone's feet staying on the end of the cliff to get across from one side to the other. But I thought this was an apt kind of metaphor to what I think a lot of us experience as we look at security in a context of DevOps. What we really want to try and talk about today is how do we build a better bridge there? How do we use tools and technologies to build a bridge that can bring DevOps and security together? I think for too long we've operated as an industry from the premise that DevOps and security are in opposition or in conflict, when in fact they can be very complementary if we think about it properly. And that's what we're really going to focus on here today. From an agenda standpoint, I'm going to take just a few minutes up front to talk about DevSecOps and data security in general and kind of what we're seeing. And this is really drawn from the experience that Fortinet has working with large organizations around the world. Fortinet as a company is one of the innovators in DevOps security, in encryption, in confidential computing, working with some of the largest organizations around the planet, both private companies as well as public sector agencies. And I'll share with you some of the experiences that I've seen and some of the lessons I've learned from talking to those customers. We're going to keep that short, though. We're going to use the majority of the time today actually in demonstrations, and that's where Arvind's going to come in. And we're going to walk you through a series of 4 demonstrations, which is kind of really practical ways and examples of how you can integrate secrets management with Kubernetes, how you can sign code, how you can securely store credentials, how you can, as you deploy out onto web platforms like AWS, how you can manage your keys there. And we'll have lots of time for questions and conversation along the way from you in that. I know Gary said up front about liking questions. We really do appreciate the questions. We'll like this to be as interactive as it can be. So if you've got at any point along the way a question, a comment, a thought, just throw it in the chat box there, and we'll take those as we go. And we'll leave a little extra time in the end as well in case there's anything we didn't cover. All right. So with that, let's start with just a quick poll question, which is, just to help us kind of target the comments, what's your primary role here? Are you primarily an information security person? Do you primarily think of yourself as a DevOps person? Do you primarily think of yourself as a DevSecOps person? Or maybe you've got a different role, that brings you here today. So if everyone could just take a moment and enter those answers in. Again, how would you primarily describe your job? Information security, DevOps, DevSecOps, or the mysterious other? Okay. And we'll take a moment as those votes are just starting to come in here on our poll.
And Dave, isn't it interesting that we even have these 3 options these days? It wasn't too long ago that this whole ecosystem didn't exist, right?
Yes, yes. I mean, DevOps at one point was just a book, right? And now it's become a way of life and a practice, and has even continues to evolve into new and interesting ways. If you haven't voted yet, so we've got a pretty good turnout there, Gary, on the poll. And it looks like we've got the biggest single group here would be from other. So we'll look forward to your comments along the way. And then our DevOps at 33%, and then a nice group of you as well in information security roles.
And David, just on that point real quickly on other,
Yeah,
I mean, this seems like a lot of people may not have clarity about kind of what this is.
Well, yeah, I think that is one of the core challenges in this whole environment, Gary. As you know, as you said, this is all pretty new, right? And I think we're all still trying to figure out, what does DevOps really mean? And for many people, it's a goal as opposed to a current state. And so I think the broader theme here, I would think of it, is how do we make application development and how do we make the application lifecycle more secure? We all know we want to go faster. We all know the business is pushing us to get more done. We all know there's great new technologies out there. We want to find a way to use those together effectively and use those together securely. And so that's why I'm hoping that all of you are here are trying to, earlier in your investigation, will gain some of that from the conversation we have here today. Right. So great. All right. Well, thank you for your input, everybody, on that. We'll do one more in a moment. So I just wanted to give a little bit of context as to why we put the spotlight on security when we're really talking about applications. I mean, again, application development is all about getting functionality in the hands of customers, delivering new capabilities to the business. DevOps is all about making that move quickly. And I think for many of us, we think of security as overhead. But just as context, we think about security as being expensive, but not having security is really expensive too. And just a few statistics that may help illustrate this. Roughly 30% of organizations are going to have a data breach in the next 2 years. The average cost of that data breach of your financial services company runs about $13 million. So there's real risk and real money associated with not being secure. There's a regulatory environment that now is starting to put hard dollars against lack of security. And again, keep in mind that the security may not be about the application itself, but it may be about all the data that's being used by the application that includes things like consumer information or personally identifiable information or medical records, whatever it may be, that are being processed by those applications. Under California law, the California Consumer Privacy Act, $750 per data record in the event of a data breach. And there's new enforcement tools that just got put in place as a result of last week's election in California. In Europe, we've had a number of years now around GDPR, making an assessment of annual revenue, and both these regulations apply to anyone who does business within these particular jurisdictions. So, if you're a company doing business in California, or if you're a company doing business in Europe, you need to be thinking about this, right?
Well, and also, David, to build on that point, in the United States, there's a patchwork of legislations pertaining to these matters, correct?
Absolutely, absolutely. And in fact, I'm going to jump out of order here, Gary, because this is the map, right? So you see, in the U.S., you've got a patchwork even within the states here, but around the world, you've got different regulations in every market, varying from kind of heavy regulation in the countries that you see indicated in red to more moderate ones that may be yellow, right? But to your point, Gary, we're even seeing differences within these markets across different jurisdictions, like California versus the rest of the U.S. Right? It's a pretty complicated environment, And to kind of just close out the note here in the end, there are hard costs, right? This isn't a theoretical risk, just as Anthem, just as Marriott, just as Desjardins. I mean, this is real money that these organizations had to put out as a result of their breaches. $100 million from Aetna. Desjardins breach last year, they've reported $108 million cost to remediate that, right? So I know that as developers, and I come out of this background from kind of prior companies. It can be frustrating to keep talking about security when I'm trying to get new functionality out, but there's a good reason why the organization's pushing us to put more attention there as we think more broadly and think around the world. Now, I think in a lot of cases, kind of where we are today in this mindset that application teams and DevOps is somehow working against security, I think it's useful to look at kind of what's going on. So what is it that the security teams worry about? And hopefully those of you who are here from information security roles, some of these may be things that you have on your mind, right? As I move forward in this new world, I've got passwords, I've got API keys, I've got service accounts, I've got all this information that really needs to be kept safe. but it also needs to be shared, right? If I deploy an application out to the cloud, I've got to have a way to store those secrets and store the passwords it's going to use, right? Sometimes those secrets are just hard coded into the applications. I was talking to one of our customers last week, a large financial services company, and one of the challenges they're trying to do is move away from the developers that actually put the password information, for example, to a database in the code itself. Because what happens when that happens? First of all, the developer has to know what that secret is, and if that database is compromised, how do you go change it? You've got to redo the application, right? But particularly in industries that have a lot of compliance requirements, there's a worry about the data. If you need real data to test your application, well, sometimes that data's got real customer information in. Where does that live? And particularly if you're starting to use cloud infrastructures, I mean, many of you are likely working with AWS, or most companies I talked to today have some combination of AWS, Azure, and GCP, usually all three. And how are you going to keep track of your data across those? How are you going to sign your code as it comes out? And as a security person, at the end of the day, when there's a breach, like what happened at Marriott or what happened at Aetna, the boss is coming to you as the security person to say, well, how come you didn't know about this and see this? And if you don't have central management and visibility, it's hard to do that. You feel really exposed, right? Well, if that's the security view of the world, let's talk about what the application view of the world is, right? For those of you who have the DevOps house, hopefully you relate to some of these, right? This is all about high velocity. This is all about getting applications out fast. And so we don't want a bunch of delays. And historically, security has been about delays. DevOps, you want to be able to pick from the tools. There's a very rich set of tools out in the world. You want to be able to pick the best ones. And in particular, with so much work happening around things like containers and Kubernetes and the cloud, you really need security tools that work with those. And let's be honest, most security tools that have been created over the last kind of decade were never designed for a world that's containers and cloud first, right? You also want to be able to kind of mix and match, but in a microservices world, you want to be able to use services that are offered by different providers and potentially even those different cloud native services. But again, it can't be a security conversation every time you want to do something new. You really just want the security to take care of itself, right? And in this, now as you see this as two lists, I mean, I've consciously put it together as as a conflict here. It does create a weak link in the security chain that we're trying to build across the organization. What I hear proposed, Gary, please.
Interruption, but you're saying such an important point here. Across the organization. In addition to the tools themselves, maybe you can share with our audience a little bit about the necessary cultural changes. From these two perspectives, security teams or DevOps teams. How do you, as an organizational leader, create a culture where this constant feedback, kind of elevates everyone instead of putting people on the spot thinking, oh no, I don't know this answer, or I made a mistake?
Yeah, Gary, I think that's a great point, because I mean, this is new territory for so many people, right? We're all learning this as we go, and in some cases we're making it up as we go. It's one of the reasons actually I put this list in here, because I do think the first step in that cultural shift is just recognizing that you've got groups of people working together in a new way under a new set of circumstances, right? And when I show you like these two lists here, for example, both these lists are correct, right? And so it's not the security people think the DevOps people are irresponsible and insecure. Although it's not the DevOps people thinking that security teams are just trying to stop things from happening, although that may be how it gets experienced. And so I do think the first step in that change is, let's just be open and let's just have an honest conversation about, hey, here's what I need, what do you need? Now, here's what you need, how do I impact that, right? And that's the starting point, recognizing and giving everybody a little bit of a break that we are all trying to figure this out as we go. But I think that starting with some understanding of the differing needs is a good point. Now,
and
I also
incentives. What about incentives? Aligning the incentives so everyone is on the same mission.
I mean, that's where you start to get into things like scorecards and metrics and how do we evaluate this, right? Finding a way to reward a developer who finds a good way to make security a part of their environment. Recognize, giving credit to the security team that takes time to go sit down and really work with their application counterparts. I'm working with another customer of ours who's actually going through that right now, right? The security team is putting together a training course for the developer teams to really help them figure out the fastest way to make security part of the application lifecycle, right? So instead of just saying you have to do this, you know, they're putting a class together on it. They're certifying people on it and giving people rewards and incentives for having completed that, right? So sometimes it's just these little things about encouragements, right? That as you suggest, Jay, which is great. I think all this also does help. If you've got technology that help to put those things together, and obviously that's what we're going to talk about more in the remainder of the session here with Arvind, right? And, you know, there are some things that we can do to really make help DevOps and security, help application team security be on the same page and be thinking about the world in the same way. You know, encryption is a really powerful tool in all of this. And if I encrypt my data, if I encrypt my passwords, I encrypt my secrets, it doesn't matter where they get left. If I have encrypted data, I can leave it sitting in the middle of a parking lot and it's still safe. And by the way, under the regulations, that's not a data breach. It's only a data breach if someone gets the data and can use it. It's not a data breach if you get the data and it's encrypted and useless. So, yeah, leave it in the back of your car. I don't recommend that, but you can, it'd be fine, right? You know, we've really got to focus on automation, and Arvind will show you some of this in the demos, right? You know, we want to be able to get, you know, secrets have to get to applications in real time. You shouldn't have someone typing in, right? It's got to be a way to do that, all driven through APIs, right? And that's where the acceleration piece comes in, right? We really want to make everything fit into an API world, because as application teams, that's what your world is all about, right? And bring in that audit capabilities so that the security teams are going to be able to actually see what's happening. And I mean, and as you see, if you get some of these stuff in this list, there's benefits in this list, I think, for both teams, right? There's things that can help make the DevOps team more productive and more effective, and there's things that can help the security team get the visibility and control that they need, but still keep the business moving forward towards that common objective, right? To break it down a little bit, you know, so as you think about the DevOps lifecycle, we're gonna walk through different stages of this today, right? You know, you've got kind of your classic flow here, left to right across the slide, and you've got a set of tools in this. When we think about security, it's going to be different things at different stages, right? At build, we're going to talk about things like code signing. At runtime, we want to talk about things like credentials and secrets. You know, as we start to get to operations, more of how do we do production deployments? How do we secure those? How do we do data protection along the way, right? So this is this life cycle of tools that we're going to try and do. And actually, in a Fortanix context, we view this as kind of more of as a figure eight, right? There's a constant iteration here, an infinity sign, however you want to think about it. There's a constant iteration here going through the cycle. On the left side, you know, planning and getting to test, you know, signing and managing secrets and including secrets along the way and credentials, and then the deployment phase of figuring out how to really operationalize this and make sure that applications can speak to each other and get the resources they need along the way. And then in a Fortanix context, we're going to add into this our product, the self-defending key management service, that's going to provide via APIs access to the capabilities that are going to be required by these applications. So really replacing the need for developers to code security or to manually add security to their applications. Instead, we're going to replace that with a simple API call out to a service that's going to provide those security services, you know, on your behalf. And so as we start to think about this model, this is when we get to this idea where we really want security to happen at the speed of DevOps. You know, keep things moving fast there, right? The product you're going to see today is our unified data security solution. The goal here is to have one piece of technology that's going to provide a range of capabilities. It's going to provide secrets management, as we often talk about in the development world. It's also going to use key management to manage and protect the data side. Tokenization will be part of that as well. Cloud key management, all in there. Everything API driven, because that's the way the applications are written, obviously. We're going to secure this in hardware, and this becomes an important point, because one of the things that makes security teams, that should make all of us a lot more comfortable, is if I have this idea of a hardware root of trust. I have a secure device where keys and secrets and encryption can take place and be stored. And you know, on the Fortanix side, we rely on the FIPS standard, which specifies military grade hardware security that can be used and secured. And to do this in a way that's going to be easy to run. This needs to be a solution that's easy to consume for the application teams, which you're going to do through your APIs, and also easy to manage from the security teams, which you're going to do through the user interface. Right? So this is some of the technology that we're going to apply to try and get that bridge between DevOps and security. And let me actually ask, Actually, and then behind the scenes in this is going to be the core technology of Fortanix, which is relying on the hardware security, providing a solution that'll work across clouds, and then really trying to make this work across the entire environment. In interest of time, let me jump to the poll here, which is, for those of you who have been looking at security, or thinking about security, just interested if you or your organization is currently using hardware security modules, HSMs. This is just one part of the solution, but I find it to be a useful indicator of the level of security that your organization is looking for, right? Organizations that want to use HSMs are generally looking for a pretty high degree of protection because they want that hardware protection. And in many cases, companies I'm talking to, one of the reasons they're talking to Fortanix is they've just been handling DevOps security and secrets through their software environment, and they're realizing there are shortcomings there, and they need to make that software environment secure in hardware.
David, as we're waiting for the results momentarily here, is there a particular sector of the economy or particular customers that you are hearing from about this that you focus on?
You know what? It's a good question, Gary. I think that the leading edge of this I would characterize as having been the leading edge of this has been the screen here has been the financial services community. Right, as organizations that have very large volumes of information that needs to be protected and needs to be secured. But as the conversation is shifting more towards kind of the topics we're talking about here, things like DevOps, the conversation is shifting more, I think, more generally across organizations. And across industries, right? Every industry right now is trying to figure out how to move faster. Every industry is right now trying to figure out how to get better functionality delivered to the hands of their customers, and that's what we're starting to help them do. Right? So I think everyone can see the poll results there. For those of you asking what's an HSM, that is a great question, and I will give you the short answer to that is a hardware security module is a specialized physical device. It often looks like a server, like a rack-mounted server that has been specifically engineered to be resistant to tampering. Right, so it gives you confidence that the work that the computing you're doing and the processing that you're doing within that environment is protected from an intruder. Someone can't get in, switch out a chip, and be tracking what you're doing. They can't get in and read the memory off that device. You have an additional set of control there. Again, not critical, but it is one of those indicators that tells you an organization's serious about security. And it looks like about a third of you are in that bucket, and a third of you aren't yet. And I suspect that those of you who are will be able to know that everything we're showing you today is based on that kind of architecture. And those of you who aren't know that that is an option. Right? So let's get to the demo portion of it, because I know that's what a lot of you came for, and I want to make sure we've got time for that. Arvin's going to be showing you some demonstrations today of different ways in which we can bring security into the DevOps toolchain. We're going to be doing all of these demonstrations using the Fortanix solution, the Fortanix self-defending key management product. That's what you'll see here happening in some of the demos. The first one we're going to talk about is introducing security at build time. And this is an example of a project we're working on with a cloud services company right now, where they are rolling out new services to their organization. This is one of our manufacturing customers, rather, excuse me, that is doing code signing for the software and the firmware being used in their devices. And that's how we're doing this here. So, Arvin, I'm going to let you run through this use case and talk about what this looks like.
Thank you, David. Thank you so much for that presentation. And Gary, feel free to interject me if I'm going too fast or I'm not keeping up with you guys. Awesome. So we're going to talk about 4 different demonstrations today. And the first one is how to secure your code as it flows through a pipeline. You're all familiar with what a pipeline is. I'm pretty sure that if you live in a developed world, you have gas pipelines running to your house or apartment. And you don't stay up at night worrying about whether there's gas leaking anywhere, do you? If you are, then you better call the gas man or the plumber. Similarly, as code flows through a pipeline, you do not want to worry about the fact that your developers are leaking secrets or putting secrets in in the wrong place or using encryption keys through the wrong mechanism. So from that standpoint, this is just an example where we picked GitLab because we feel it's a good holistic platform that demonstrates the entire CI/CD process, and it's fairly robust and modern in the sense that it integrates with Kubernetes. So if some of you are already running self-managed Kubernetes clusters, you'll be happy to know that GitLab can compile your code, can build your code, can do QA against your code, and can even provision that in your containers. So all along in your journey in that code pipeline, Fortanix can provide different kind of security objects. And in today's demo, we'll see something very simple and straightforward, which is called as a secret. It could be an API key, it could be a password, it could be any sort of secret. And essentially, your code, as it goes through the pipeline, doesn't have to know where the secret is. The secret magically shows up depending upon where the code is in the pipeline, and Fortanix injects that secret into the pipeline based on some annotations that you define in GitLab. So with that, let's transition out to the demo, and I'll provide some commentary based on the screens that you see.
All right, there we go.
Okay, so first off, we have 3 images on Docker. You can go grab those. Those are our images for deploying this in your cluster. It's all available for free.
Arvin, sorry about that. Operator error on my part. Let me get you
going. That's okay.
Again.
So Control Space David pauses the video.
Yep.
Okay. So we're doing here is we already have deployed a Kubernetes cluster, and on the cluster we have a secrets injector, which is backend mutating webhook, which does the secret sauce here. And it doesn't have any root secrets of your project. So as your project comes into GitLab and you define what secrets it needs, the backend Kubernetes secrets injector analyzes the code or the annotations on the code, and based on that, it provisions the secret. So we're just setting up the initial plumbing here, which is setting up a project in GitLab. And once we have the project, the developer clones the project into the local environment. So this could be a client or a dev machine. And it's an empty project to start off with. And the maintainer or the administrator of the code would basically provision the GitLab executor, which is responsible for building this code in a container on Kubernetes. So as you can see here, the runner is being registered with a runner registration key. This can get rotated out. And there's an annotation on this runner that injects a secret into the container. Now you can have 2 kinds of injections. You can have these injections that are defined by your repository maintainer, so that those secrets always enter your code, or you can define your own secrets through your GitLab CI YAML, which is a project or a repo-driven secret specification. So thanks for pausing that, David. And so right now, this is the Kubernetes dashboard. And as you can see here, there's an orange line which highlights the runner from GitLab. And right on top of that, there's a Fortanix secrets injector. And that secrets injector is basically the mutating webhook, if you're familiar with Kubernetes. And that is what monitors any incoming pods, whether it's a build pod, whether it's a runtime pod, or what have you. And if it has those annotations, and if it has the authorization, it'll go out into the HSM, which is the Fortanix HSM, and pull those secrets automatically. So yeah. So the runner needs to be updated. So we just added a small tag there so that the project maintainer can add their own annotations. And now the secret injector is waiting for a pod to come in. So this was the initial setup done for GitLab. So we set up the project, we set up the runner, and now we can see that the runner is showing up in the GitLab project. And so now it's time for the developer to go and make the first edit. So nothing fancy, just updating a README here with Hello GitLab. And it could be a Java project, it could be any kind of project that you're building. Fortanix itself is built on Rust. Our entire software is written on the Rust platforms, which is considerably more secure than C or C++. And as you can tell, the developer is making a commit and pushing the code into GitLab. And as soon as that code hits the GitLab, if the runner is configured correctly, we should have got a pipeline. But what happens is GitLab has this default setting called as auto DevOps. And with auto DevOps turned on, it needs additional settings. So we disable the auto DevOps. And now when we push the code again, when we make an edit to the GitLab CI YAML and copy the annotations on this, we'll be ready to build the first pipeline. So when we first added the README, there was no build specification. With the GitLab CI YAML, we add a build specification, and we are going to check that into the repository as well. So you're seeing that the developer is typing their name and password. Obviously, you want to automate that with SSH keys, and if going a step further with an SSH CA. So as you can see, we did the push, and there was a pipeline that came in. And the pipeline basically automatically injects into the Kubernetes cluster. And you can see in the secrets injector audit trail that there was a mutation that happened. And the mutation was successfully done for a runner, and the build has passed. And it tells you the output of the build. And as you can see, there was an annotation injected by the runner itself. It's a default secret that the runner specified. And where did that secret come from? It came from Fortanic's self-defending KMS. This is the UI that you see in front of you right now. And essentially, we enforce role-based access control so that the secret can only be injected if the entire environment is set up correctly and the build identity matches the application set up in Fortanix. So next up, we will edit this a little bit further. We'll add a variable in here to inject a certificate. So the first time we injected just a regular string, which is Postgres docs as a password. And now what we'll do is we'll put an annotation in this build spec, and we'll basically say, give us a certificate from the HSM. So this way, you don't have to carry Java key stores, so you don't have to basically rely on some of the traditional mechanisms to provide you the security that you need in your DevOps process. So you can see that as the developer pushed it, everything is automated. The build automatically runs on the cluster, and you can see the second mutation in the secrets injector right now. And there is evidence of that. And if you look at the audit trail, there is the certificate. Mm-hmm. So taking it a step further, you can also have it such that there is no printing of secrets into the log of the GitLab. This is obviously for demonstration purposes. If you didn't print it, how will we prove to you that we pulled the secret? But in an ideal setting, you wouldn't want to print that. And then the final injection is just to show that if this is not a canned demo, is hello CI/CD. It's a completely new secret. We'll show you how easy it is to create a secret. You can either use the UI, you can use the API, and what have you. So this is just a secret. And there's two kinds of secrets we support, opaque object and secrets. The only difference is the length. Secrets tend to be smaller. Opaques tend to be larger. It could be blobs, files, what have you. So this is a simple JSON data, a payload that will get injected into the pipeline here. And one last push, and we should be good to finish this demonstration. Okay, I managed to catch this. This is an interesting thing. If you notice here, there was 3 secrets there, and the third one was the actual mutation and the log of the mutation. So as you play this forward, you'll see that the audit trail in the pipeline shows you that JSON payload. So there was there's the JSON object, and then the other 2 annotations have been left intact, so those came in as well. And if you look at the audit trail right now and refresh this, you'll notice that in Fortanix, everything is logged. And the logs are stored in a tamper-proof HSM, and you can enable log rotation and log purging policies and so on and so forth based on your enterprise. But by default, everything gets logged in the HSM. Which is easy because when the audit man comes knocking, you do not want to be fumbling.
Cool. Excellent.
I have a question about that, if you don't mind. And Arvind, before we were starting, I mentioned to you that I just got my first DevOps certification. On the human stuff, I scored 100. On the software stuff, I got a 35. So forgive this question, but what's the advantage of using a third-party system like what we're talking about here versus, cloud native or open source, things like that?
Definitely. David, do you want to take that and I follow up?
Arvind, go ahead. Why don't you start on that?
Okay. So yeah, I think the word third party here is always a relative thing. It depends on who's the first party, right? You always encounter this word third party. So if cloud is your first party, then yes, you can think of us as third party. But if cloud is your third party, then we can be the first party. So it really depends on that word that you use here. But the main advantage that you get out of using an HSM like Fortanix is you get full control of your secrets and certificates. You also can deploy this across various kinds of environments. So you have, as an enterprise, you have way more control over the secrets, the keys, the auditing, and at the end of the day, this is subpoena proof.
Yeah.
Forgive me, Dave, one more quick question.
Yeah.
You can help our audience understand a little bit about the risk management benefits of the technology that you're putting forth in terms of exercising due care, in a fiduciary sense.
Yeah, well, I mean, it's interesting. I mean, if you think here about the example that Arvind was showing the demo over there, right? I mean, so let's say that your application was needing to log in and access transaction records in a banking environment, right? That's got sensitive information in it, right? And so the credentials are going to be used to access that data. You want to be able to show due care for those, as that's critical information. If a hacker or an unauthorized party were to have that information, they could potentially have access to customers' banking information, banking assets, and whatnot, right? And so I think, from an audit standpoint, the idea that you actually have a secure place to store that kind of information, I think becomes really critical. And it's just, it's the right thing to do. But it's also just a way of fulfilling your responsibilities there, of making sure that your developers should not be having access to all the databases that their applications touch, and they don't need that access, right? You want to know that those access credentials are being stored and protected somewhere, like what Arvind just showed you here.
That's a great segue, David. Actually, the third demonstration exactly talks about that. So
yeah. And everyone else on the call here, if you got any other questions as we go through here, we're very happy to take those as we go, and eager to answer questions you may have. So,
David, we have a good one that's relevant here, which is it possible to use the Fortanix system both in cloud and in-house and manage different deployments from the same central environment?
Yes, absolutely. So in the Fortanix architecture, and we think that's actually really important, Gary, right? Because application environments today are very much hybrid environments. You've got some stuff running on premises still. Often that's kind of the older legacy applications. You got a bunch of new stuff moving to the cloud. You need to be able to secure both of those, right? So in the Fortanix environment, you can run Fortanix in an on-premises data center solution, where the customers typically do, because then they get access to the secure hardware. But you can be serving up secrets or providing data security to applications and data that may exist on really any cloud platform that's out there. And if you wanted to, you can do the reverse as well. You can actually run it in a cloud platform and provide services back on-premises, although so far that hasn't been as common in terms of how people are thinking about it. But I think that one solution becomes important.
Yeah, sorry, if you can clarify, another questioner asks, can we download and store our secrets out of Fortanix?
Download and store them. Actually,
that's right. You could migrate the secrets. You could basically set up an automation to do the migration. It could be a one-time migration. It could be a rolling migration where you have the secrets in an existing repository somewhere, and you're gradually synchronizing them and migrating away from that legacy system. So it really depends on the environment. Happy to take that offline.
Yeah. Great question, though. Great question. Well, why don't we go ahead and take a look at the next piece of it here, which is kind of code signing, right? Secure release packaging. In Fortanix, we're working with one of our large energy customers who does have an extensive in-house development team, and they want to be able to use code signing as a way of validating that the application work they're doing in-house is actually secure and ready to be distributed. And so I'll let Arvind talk a little bit about how we do that and show you what that looks like.
Definitely. So when it comes to code signing, you're talking about two major things here. One is, as developers commit the code into the pipeline, which we saw in the previous demonstration, you want these commits to be have integrity on them. So essentially, the person who is making the commit is the person signing off on that commit. So that's the developer-based code signing. And then as an enterprise, you release applications out in the open. If you're a consumer-facing company, then you may be developing applications where you put into public app stores, or if you are in a B2B space, you might be developing applications for your end customers and what have you. So those kind of artifacts need to be signed as well. And there's, depending upon whom you're catering to, the value of code commit signing and release signing can vary. But regardless, I think the point is the key that is responsible for signing the artifact has to be in an HSM. The only reason why it should be outside an HSM is obviously if it has to be less secure. So otherwise, you want to be always putting that key in the HSM, and you want to access the signing inside the HSM. So that's something that's critical. You do not want to sign outside the HSM. So the question comes to mind then is, well, what is my throughput on that? So Fortanix can support a large cluster or a small cluster, depending upon how you deploy this. And the performance of the cluster linearly scales as you add nodes to it. We ourselves use Kubernetes inside our architecture, so essentially it's a fully horizontally scalable architecture. So that said, the demonstration that you see here is basically taking a simple Java project and building it, and then getting it signed in the HSM. There's an additional layer. It's a layered demonstration. As you go through it, you can play it.
Okay.
As you go through it, you'll see the way the developer builds the security higher up. So at first, he's simply using USB tethered HSM, which is you can get on the market for like a couple of dollars. It could be a YubiKey, it could be any sort of like HSMs that you plug into your USB port, and you can sign off of that. That's basically what a lot of people are doing today. And then the second thing is you can sign using the HSM, either from Fortanix or from someone else, but essentially your key then is secured in Fortanix. But then that requires that the application that calls the signing has to store an API key. And to make it even more secure, that API key itself can be fully eliminated by having the client or the build environment automatically authenticate into the HSM using a client certificate. So we have two applications here. You have an integrity check application, which is using an API key, and you have the code signing application, which is using a certificate. So it's a parallel track, depending upon how fast of signing you require and how secure you require, you can go up the food chain or down the food chain. So this is the Java repository here. And just for the sake of transparency, the developer is deleting the old jar and verifying that the API key is in the environment. So, and once that is there is a Java key store here. Fortanix provides a JCE connector, wherein we simply give you the interface that the key actually stays in the HSM, and the JCE simply gives you a proxy or a reference for the key. So as I said, there's 4 demonstrations here that are packed in here. One is the YubiKey using the YKCS11. That's their version of PKCS11. And you can see that the developer has a local YubiKey here. And using slot 9C, he's going to sign his artifact locally. So this is good for development purposes or just some standalone like testing, but you do not want to be doing this with any commercial code, obviously. So you can see that the application was signed and is also verified. It got the SMK in the Java signature verification, which stands for it's secure and it's stored using a key in verified appliance. So the second example is using an API key. So we set the API key for the Fortanix application and we sign using this key. And then as soon as this is signed, you can the developer tries to verify this, and you can distribute the artifact. And then if it's verified, you get the SMK, which is again a proof of verification. Now there's 2 more options. There's a PKCS12 option where you can store a client certificate in a local PKCS12 file on the build machine or the client machine, and then the security is reliant on basically how secure is that PKCS12 file, and essentially you can protect a PKCS12 file with a password, but you still have to put that password somewhere. So in security, there's a saying, where are your turtles hidden? So you don't want to be hiding turtles, because turtles are difficult to hide. So essentially, the third demonstration here was doing the PKCS12, and the final demonstration here is actually storing the certificate on the USB key and signing with that certificate. So the client certificate stays in the local USB, and the server certificate is actually what is doing the signing of the artifact, and you get the audit trail again at the end of it.
Cool. Arvind, thank you for that.
Sure.
Again, I think code signing is one of those things that I think was fairly straightforward in kind of traditional application environments where you might only have a new release coming out every 3 months, every 6 months, every however long. But if you as you start to move into a DevOps world where you may be doing releases every 2 weeks or every day, or even some of the big software companies here in Silicon Valley every hour, you're going to need something that scales more at this kind of rate. So good. We got about 10 minutes. We have 15 minutes left in our session today. Let's try and show you 2 more things here, 2 more examples I think will be interesting. The next one is security at deployment. And this is the case where we want to talk about how and where do we store the secrets that are going to be used by applications at the time of deployment. And so Arvind, I'll let you walk through what this demo looks like.
Sure. So David, actually you brought this up the other time that the developers, once you deploy the application and it's signed, everything is good, it's out of the door. The security doesn't end there. You still have to worry about maintaining your applications for your customers. And so most often that'll require somebody giving you a Slack message or an email saying that, hey, I need a password. So you don't want to be handling passwords in emails or Slack. And that's why you have short-lived credentials. And that's become the de facto now in the security world. So this demonstration, you can play this forward. I'll just speak to it. But you have the administrator who's setting up an app, which is the normal procedure that you've been seeing so far. And you have a developer who's requesting a password, a temporary password, into the app. In this case, we'll be actually demonstrating this through a plugin. So Fortanix, as an HSM, allows you to extend what the HSM is capable of doing beyond what ships with the box. So we have a plugin here called DevOps Credentials. And this particular plugin is basically reaching out to a Postgres database and with a pre-configured role that's only allowed to create temporary credentials. So there's 2 operations that the plugin supports. So Fortanix plugins typically interact with JSON today, but you can extend that. And so you can make REST API calls. Right now, I'm just, we're doing this demonstration in the UI, but basically all of the operations that you see in the Fortanix UI can be automated through the API. And so once the Postgres database is configured, the developer can then request for credentials. So they would typically do that through remote shell command, or through a CLI, or some of their favorite developer tools. This could also be like an Ansible lookup. So you have Ansible, or Puppet, which is used for provisioning secrets and pulling secrets at runtime and operations time. So it could be an Ansible lookup into the plugin to get a short-lived credential. So as you saw, the developer is trying to access this with a DevOps user ID, and he's denied. And so the developer is now going to request it, a temporary credential called DevOps with the create command. And he has to specify explicitly which database, and it expires in 2 hours. So he gets a username called DevOps _ a set of random characters and a password. So now the developer can authenticate using that into the target machine. And you can customize this. Like I said, the plugin is pre-built by Fortanix. We have a library on GitHub where you can pull down some of these plugins. But our customers most often extend these plugins way beyond what we had initially thought out to be. So they basically customize this for their own environments and to suit their own CI/CD pipelines and other DevSecOps requirements. So in this case, once the credential is provided, as an administrator, you don't have to worry about the password because the password automatically gets revoked after 2 hours. Or obviously you can revoke it explicitly and try to then authenticate. And because the password is revoked manually by the admin, essentially it prevents the DBA or the DevOps guy from trying to access the database or the target resource again. And the same thing can be extended to pretty much most of the other databases or credentials. So you can sort of build an entire privileged access control mechanism in Fortanix. That's it.
Very cool, Arvind. Very cool. You know, and to the conversation we were having a few minutes ago, right? I think this is, and Gary, your question about kind of, you know, security responsibilities. The short-lived credentials are a great way to do it, right? You know, there's no reason for someone to have the post-it note on their monitor with the secrets that they're using in their application when you have a system that can just give it to them in real time as they need that, and then revoke them automatically in the back end. So again, Gary, we talked before about kind of aligning the teams. I think this is a good example of where, you know, both teams can get what they need if you set things up properly. As a developer, I can get immediate access to the systems I need for testing and validation. As a security person, I know that I'm not creating a security vulnerability or opening a gap there. So, good. Why don't we? Let's see, Gary. Any other questions? I think we've covered the questions for the moment.
You have a choice. DevOps here live. You can go to the fourth demo. We have about 9 minutes, and we also have a poll question.
Yeah. So why don't actually, Arvind? There was a question there I think we missed about extending the temp user time after 2 hours. Is there a way to do that?
Absolutely. Absolutely. Okay. So that's configurable, and you can also rotate the secret. So that towards the trailing end of that demonstration, you saw a rotate operation. But you can also default that instead of 2, you can set it to 24 hours. It's a plugin, so if you get your hands on that plugin, you can basically set the default to your preference.
Perfect, perfect. And then I see another one here, a question from Luca about the API that generates the temporary password. How is that secured when we're using it in the kind of demo you just talked about?
Right. So the plugins I mentioned briefly, maybe I mentioned it in passing, but the plugin itself is a piece of code. And so the plugin is making an API call to the Postgres database, so to speak. And so you want that plugin to be executing inside the HSM because that itself needs to be secure. So with Fortanix, you get the plugin running inside the secure enclave that is provisioned by the HSM. So essentially, the REST API call originates in the HSM and terminates in the HSM, thereby guaranteeing the security of the API.
Perfect, perfect. That's great. That's great. Okay, good. Good. Some great questions there, and I do think that you know, to your question, Luca, that is one of the reasons. So the polling question we had a few minutes ago about kind of that hardware of trust. That's one of the advantages of that, right? You have confidence that the key stored someplace and originates someplace that's going to be protected and is actually processed in that environment too. Those are some great comments and questions there. And I think there was also a question about recording the program, and we absolutely will be sharing recordings of this. So you've got access to it for future reference, and are certainly happy to do more there. Sorry, Gary, you were going. I think you were going to take us in a little different direction there before I jumped into those questions.
I just wanted to make sure that how would our audience get more information, you know, about everything that you're doing?
Yeah, there's a couple of options for that. Let me skip past that here. There's a couple options for that, right? So we actually have a trial available for the Fortanix product, right? So you can actually go to Fortanix SDKMS@fortanix.com. You can create an account, and you can actually run the exact same demos we've been showing here and just play around with it and get a feel for it with your own environment. And happy to have you do that. And that's open to also invite anyone who's watched here today who's interested in it to go ahead and do that. You can also reach Arvind and I as a follow-up here. info@fortanix.com. Happy to answer any questions you've got. We'll take any questions that I think we've been able to cover the questions that have come in here. If you got any other questions, that you're certainly welcome to reach out to us directly. Sorry, Gary, what's that?
Forgive the interruption, David. Arvin, we have an interesting question here. How does it work? If you can please amplify, how does it work if you have a hybrid application with some parts in the cloud, and some parts on premise?
Yeah, so I think, Gary, it depends on what the application needs. If the application is trying to use keys, then the keys can be protected in the HSM on-prem, and then you can have a policy. So Fortanix, the HSM, has a very robust policy engine, and you can project those keys based on those policies, and you can escrow those keys into the cloud for use in cloud-native applications. That's one way to do it. You can also run Fortanix, as David was alluding to earlier, in the cloud, and then have a hybrid solution of the HSM itself, whereby you have on-prem applications and cloud applications accessing those same keys in a cogent fashion. And if you're talking about data protection, that was not the subject of today's demonstration, but if you're talking about tokenization or format preserving encryption, then that's a slightly different path. Depending upon your application, Fortanix can be pervasively tokenizing or detokenizing the data, and the architectures for that are quite interesting. So happy to take that up as a follow-up if that's the intent of the question.
And thank you. Yes, and David, so most of our audience probably come from larger enterprises, but what about the SMB use cases of the technology?
It's interesting because I think some of the most, as you've seen, Gary, some of the most innovative software development right now is happening actually in mid-sized organizations, right? Because you're really close to your customer and it really matters to move fast. There's a number of ways to consume these sorts of technologies. For a large enterprise, they typically will want to have some of this hardware grounded security running in a location that they trust. That could be their data center, their outsourced provider. For the SMBs, we actually see more interest in consuming as a service that might be available from a third party. So for example, Fortanix works with Equinix, who I'm sure many are familiar with. Equinix is a service called Smart Key. And Equinix Smart Key can give you the same capabilities we've been demonstrating here today. It's the same technology you've seen here, just made available in a different consumption model. And for a mid-sized organization that might only have a handful of secrets or a small number of code modules where certificates are needed, that sort of solution can be a very easy, fast to implement, low overhead way of doing it. So again, I think one of your earlier questions, Gary, I think, and someone asked as well in the chat, I think one of the themes here is that as we think about security for applications going forward, we need to recognize that we've got we can't make any assumptions about where that application is going to live or where the data axon is going to live. It could literally be anywhere. And so therefore it's important to have that complete flexibility of how we build out and deploy these solutions. So that may be in a data center, that may be in the cloud, that may be as a SaaS services like Equinix or any combination of those. The key is if you've got the right interface points with the APIs, you've got the right underlying trust, you've got kind of the core ability to encrypt and protect all of these elements, that's what's going to give you the security we need and kind of create that bridge that we talked about at the very start of the session.
Well, on that note, thanks so much to Arvin and David. On a personal note, my head is just exploding. This is just incredible. So, thanks so much for sharing your knowledge and your experience and your leading edge, thinking about what's happening now, what's going to happen in the future. So thanks again. As I mentioned earlier, we do have 4 lucky. You're welcome. We do have 4 lucky winners for today's $25 Amazon gift card giveaway. The winners are Luca C., Myron L., Wayne M., and Kathy M. Congratulations. Don't spend it all in one place. Someone from the DevOps team will send you an email to confirm your address and get the gift card over to you promptly. And as I mentioned, this webinar is being recorded and the slides will be available to you on demand at devops.com in a couple of hours. We'll be sending you a link to the slides and the recording as well, as David mentioned. So on behalf of devops.com and Arvin and David, thank you all so much for spending an hour of your incredibly valuable time. We truly appreciate it, and we look forward to seeing you again on the next devops.com webinar. In the meantime, stay safe and be well.
Thank you, Gary.